So next we are going to be talking about sections 3, 4, and 5, which is slope, writing linear equations, and interpreting graphs. Now we've already done a little bit with writing our linear equations, so we're going to just continue with what we've been working on, and we're going to add some more of the interpreting pieces. Okay? And we're going to make the writing of our equations a little bit harder. Okay? So just as a reminder, from our Algebra 1, we have our different forms, our slope, and then our x and y intercepts. So we're just going to review quickly what those things mean. So for our point slope form, this is y minus y1 equals our slope m times x minus x1. So remember, our m represents the slope, and then that x1, y1 is a point. Okay. So that means that we would be replacing our y1, our m, and our x1 with the appropriate number. And typically, if we are using our point slope form, we either have 2 points and we can figure out a slope from those 2 points and we can substitute in here, or if we're just given a slope and a point, that is when we would use this form right here. And then for our slope-intercept, that's the y equals mx plus b. So m is still slope, and b represents our y-intercept. Okay. And then standard form is ax plus by equals c. And our a, b, and c are integers. Okay. So that means that we can't have any fractions or decimals. Okay. And typically our slope-intercept form we're using to graph because we would just start at our y-intercept and then use our slope to get to our second point. And then if we have context, meaning some type of story problem, we could be starting in our slope-intercept form like we did on several of these. So this would be an example of our slope-intercept form. Same thing on our previous, that was slope-intercept form. Or sometimes, depending on the information we are given, we could be starting in our standard form, but again, that's going to be if we are given context. If we're just starting with 2 points or a point and a slope, then we are going to be in this point slope form. Okay. And then our slope formula from 2 points is our y2 minus y1 over x2 minus x1. And remember, those subscripts represent our points. So x1, y1 go together, and x2, y2 belong together. Let me fix my subscript here because that looked like a 7. There we go. Okay. Or we can think of it as that rise over run. Okay. And then for the x-intercept, we are talking about where our line is crossing the x-axis. And then our y-intercept is crossing the y-axis. So if we were thinking about it in terms of a graph, this is what my line looked like. Here would be my x-intercept, and this one would be the y-intercept. Okay. And really, our x-intercept can be anywhere on this line. So no matter where we are at on this line, our y value is always 0. And then we will have some number in our x position. And then same idea for this one. So on the y-axis, no matter where we are at on this, our x value is always 0. And then we will have wherever it's crossing as our number in the y position. Okay. Now some things that we need to keep in mind. So I've said a few of them. So let's just add those to our notes here. So if we have 2 points, we are going to use that slope-intercept form. So if you have 2 points or a point and slope, we are going to use slope-intercept, point slope form. If we are going to graph, we are going to use the slope-intercept form. And also keep in mind that our context is very important. So we need to pay attention to the context. Okay. So really we need to carefully read each problem. Okay. So next we're just going to go through a bunch of examples. So again, our main focus in this is being able to interpret our equations and how the graphs are affected, or take a graph and figure out how the equation is being affected, and when we need to substitute stuff in, or if we need to talk about domain and range. Okay, so we're just going to start with several practice problems. So I would like you to go ahead and pause the video and read through this first problem. Now, as we are reading through this, we are given the equation for this line right here. So we call that the line of best fit. Now, we're not going to be calculating these by hand. If you take AP Stats next year, you will do more of that type of calculation. So for right now, we want to be able to focus on interpreting our equation and our graph. Okay. So for part A, it says, what is the predicted time spent doing homework for a student who spends 12 hours watching TV? And if we're looking at this, our watching TV is represented by our X value, and then time spent doing homework is represented by Y. So I'm just substituting that 12 in for the appropriate variable. So in this case, we are substituting 12 into our X and then simplifying. And you can do this right on your calculator. Now, if you are using one of the graphing calculators, make sure that you are using the negative key at the bottom of your calculator and not the subtraction sign. We have to do that anytime we have a negative as our first number that we're going to type in. Okay? And you can type that whole thing in exactly how it looks, or you can do it in parts. So I'm going to type mine all in at once, and we are going to end up with 15.67, and then we always need to label our answers anytime we have context. And to check to see if my answer makes sense, I should be able to go to 12 here, and then when I go up to hit that line, it should be at about that 15.67. So here's my 12, and it's just above that 16, or excuse me, it would be just below that. So my answer does make sense. Okay. And then next one, what is the predicted time spent doing homework for a student who doesn't spend any time watching TV? So that just means that I'm spending 0 time. So again, I'm just plugging that in for the appropriate value. So in this case, it's going to be that X again. And then we are simplifying that. So if I simplify, that is going to give me 25.87 hours. And then C, for an increase of 1 hour in time spent watching TV, what is the predicted decrease in time spent doing homework? So this is really just a fancy way of asking you for the slope of the problem. So again, it's asking for an increase in 1 hour. So as we go this way on our graph, what is the increase? Okay, so if I'm looking at this as I'm going this way, we are going down, so that's where the decreasing is. And then I'm just figuring out slope, which I'm using my equation for since I have that. So my slope is going to be that 0.82. And I'm not going to include the negative in that because in this statement, it's asking for the predicted decrease, which is implying that negative answer. Right. So again, I would like you to go ahead and pause the video and then answer those next 3 questions. And while you guys are doing that, I noticed that I made a mistake in problem 1. I'm going to go back and fix that. So my equation is right, but I accidentally typed it into my calculator wrong. So this should actually be 16.03 hours. Okay. All right. And then again, we should have paused the video, working through that next one. So again, here is the equation we are working with. So that represents this line right here. And then our scatter plot, as we're looking at this, X is the number of hours worked, and the amount of money spent is our Y value. So again, I'm just plugging my things in for the correct variable and then simplifying. So if we are trying to predict the amount of money spent on entertainment for a student who worked 10 hours, that means I'm substituting 10 into the X and simplifying. Okay. Now again, you can type that in pieces, or you can do it all at once on your calculator. Double check that you are typing it in correctly. And we should be getting 28.67, and then our label for this would be money, so I need to include my dollar symbol. Okay. And then if we are trying to predict the amount of money spent on entertainment for a student who doesn't work any hours, we're assuming that our X value would be 0. So again, I'm just substituting that in and simplifying. So our answer for this one will be 11.07. And again, I label as money, so I need to include my dollar symbol. And then for an increase of 1 hour in time worked, what is the predicted increase in the amount of money spent? So again, predicted increase is asking for that slope, and we are leaving it positive, whatever it happens to be. So I'm just going to go back to my equation. So in my equation, my slope is that 1.76. So really that means as every time I go over 1 this way, I'm going up that 1.76. All right, so as we continue, still doing our interpretations. So again, I would like you to pause the video, read through problem 3, and see if you can answer parts A, B, and C. So as we're looking at this, we are comparing our weight in pounds to our fuel efficiency, which is our miles per gallon. So this is the line that we want to take a look at as we're looking over our questions. So for 25 vehicles, as the weight increases, okay, so that means as we go this way on the graph, the fuel efficiency tends to what? So as I'm looking at this, as we're moving this way for our X's, we are going down for the Y's. So my answer for this one should be decrease. And then as we look at our next question, for these 25 vehicles, there is blank correlation between weight and fuel efficiency. So this is just really asking for our slope. So is it a positive or a negative correlation? So because our graph is going down, that is going to be negative. And then for part C, using our line of best fit, we would predict that a vehicle weighing 3,000 pounds would have a fuel efficiency of approximately blank miles per gallon. So I'm just going to go to 3,000 on my x-axis, and I'm going to go straight up until I hit the line. Okay, so we're using that line provided to make this prediction. So the y value here would be about 30. So, and it is an approximation, so we are just rounding to whatever we think it is. So if you decided to use 29.9, that would also be an acceptable answer for this. All right, so again, go ahead and pause our video and then answer our next set of questions. So we are comparing our years of experience to pay. So it looks like as our years of experience increases, so should our pay, which is the answer to our first question. So as experience increases, pay tends to increase. And for our cashiers, there is blank correlation between experience and pay. So since our line is going up, this is going to be positive. And then for our prediction, that 9 years is on our experience. So on the x-axis, I'm going to 9, going up until I hit that graph and putting that point there. And then as I'm looking at this, we're just taking our best guess as to where that y value is. So it doesn't quite look like it's exactly halfway in between. So I'm going to say 16.5. But if you did say 17, that would still be a correct answer. And it should be dollars, which we have that word there, so I don't need to include my dollar sign. All right, so as we keep going, again, we're just taking our graphs and interpreting. So I'm going to stop the video here and then start a new one to go over these problems.